All right, really quickly, I want to show you the graph of this last one that we looked at because it cut me off. Okay, anyway, here you go. So you know that it's undefined at 0, so there's our asymptote that we knew about, and we know that it's increasing, increasing, increasing until this point right here, which is -1 and -4/3. So it's increasing, and then all of a sudden it's decreasing. And then you can see how it's actually still decreasing again. This is why there's no relative extrema there. This is our relative max and our relative min, because it's a peak and a valley. So relative max, relative min, and then it goes increasing until infinity. So let's look at the very last one and see what we can find out from that one. If it wants to open on me. Okay. All right. It's thinking, thinking, thinking. Okay. Come on, we only have 15 minutes to record. It's just going to think. Okay, so here's our last one. So let's figure out relative extrema on this one as well. Okay, so the first thing we do is we figure out any domain restrictions that it has, because those are going to be numbers that we want to look at. Are there any domain restrictions? No, it's a polynomial. So polynomials don't have domain restrictions, right? They're real. Their domain is all real numbers. So our domain is all real numbers. So we don't need to look at any domain restrictions. So the next thing we need to do, our next step, that's step number 1. Step number 2 is that we look at the derivative. Okay, so let's find the derivative. F prime of x equals 3x squared minus 6x plus 3. So that's our derivative. And then we see, where is the derivative equal to 0? And where is the derivative undefined? Okay, those are our two things to find critical numbers. So remember, the derivative is equal to 0, where the numerator is equal to 0. So f prime of x is equal to 0, where 3x squared minus 6x plus 3 is equal to 0. Then f prime of x is never undefined because there is no denominator. So denominator can't equal 0 because there is none. We're also not taking the square root of a negative number, so it's never undefined. So let's just figure out where it's equal to 0. 3x squared minus 6x plus 3 equals 0. We go way back and remember factoring. You always take out a common factor first before you do any factoring, because you are going to, maybe you learn slide and divide or area model, which is the better model, but that's okay. Maybe you learned all these different things. If you don't take that greatest common factor out, it's going to kind of get screwed up and you're going to get frustrated. So anyway, we're going to factor this. And we're going to find that 3x minus 1 times x minus 1 is going to give us those factors that we need. So when x minus 1 equals 0, our whole function is equal to 0. So our function is equal to 0, x equals 1. And just x equals 1. What? We only have one critical number? That's amazing. This is so much easier, right? Okay, so we know our critical number is x equals 1. So now we have to figure out what's going on with f prime at our critical number and any domain restrictions. But we don't have any domain restrictions. So really, our f prime number line is going to be really simple. We just need to find out what's going on at x equals 1 before and after x equals 1. So again, I'm going to rewrite my f prime so that we remember it here. We're trying to figure out what's going on with f prime. That's why it's our f prime number line. Okay? I should make a song. F prime number line. It rhymes, okay? That's the best I got. All right. So before x equals 1, x is 0, right? And our function is positive because, 0 plus 0 plus 3 equals positive 3. After x equals 1, we have something like 2. So, we could put in 100 if we wanted, but we won't. we have 12 minus 12 plus 3, which is positive. If we put in 100, we would still get a positive number because this x squared is going to grow way faster than this x, so we're still going to have a positive number. So, what? You mean this function is increasing, and then it's increasing? So it's f is increasing, and then the derivative is equal to 0 for some reason, and we'll look at what that looks like, and then it's increasing again. So, do we have any relative min or max? Well, the only time we ever have a relative min or a relative max is when the derivative changes signs, okay? So our relative extrema are always where the derivative changes signs. The derivative never changes signs here. It's always positive. So the derivative is always positive, which means the function is always increasing. So there is no relative extrema on this one. So, no relative extrema. And what are the intervals where it's increasing? Well, f is increasing from negative infinity to positive infinity. And where is it decreasing? F is decreasing never. And that's it. What? That was the easy one. Okay, so this is what we learned from this one, and just like some terminology that you might want to know. So basically what we said is this example is strictly monotonic, which means that it's either always increasing or always decreasing. This is a word you're going to see a lot, okay? Monotonic. So just remember that word. Monotonic means that this function is always either increasing or always decreasing. So it has no relative min or max, and it really taught us a few things. The first thing it taught us is that not every critical number produces a relative min or max. So just because your derivative is equal to 0 doesn't mean you have a relative min or max. And you know what? Let's just look at this function. Let me just show you what this function looks like. It's this one here. Okay, because you're like, what? How can it be doing this? All right, this is how it can be doing this. Do you see here? It's increasing, 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 and then it flattens out for just a minute. That's where our derivative is equal to 0, right there. And then it's increasing, 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 increasing. See, it never actually decreases. So there really is no relative min or max. There's no peak or valley in this one because it never goes from increasing to decreasing. So there's not a peak. This is not a peak, okay? Because it doesn't go from increasing to decreasing. It goes from increasing to 0 and then increasing again. So this is a strictly monotonic function. It's always increasing. Again, a function that was always decreasing would also produce that. Let's see if... Nope, that didn't do it. I wonder if we change all of these signs. Aha! This would be also a strictly monotonic function. Do you see how it's always decreasing? And then it flattens out and it's decreasing again. So again, here's our critical number right here. Our critical number is at x equals 1. But it's actually not a relative min or max. That's why we test them every time, because it may or may not be a relative min or max. So, this function was actually a kind of easy one, right? Our answer would be that it is increasing, that it's increasing all the time and never decreasing. So I hope you have a little bit better understanding of increasing, decreasing, all of that stuff. The takeaway, again, the takeaway here is a function is increasing, and this is, I'll give you a foldable tomorrow. So f of x is increasing when f prime of x is positive. F of x is decreasing when f prime of x is negative. So do you see how I did these double arrows on this? Important part. If the derivative is negative, then f is decreasing. Okay? So if the derivative is negative, the function is decreasing. If the function is decreasing, f prime is negative. If the derivative is positive, the function is increasing. If the function is increasing, the derivative is positive. Okay, so those are important things to recognize. It goes back and forth. So if you see that the derivative is positive, you know for a fact it's increasing. Or if you know that the function is increasing, you know the derivative is positive. The other takeaway is that the function has a relative min when the derivative changes from negative to positive, and the function has a relative max when the derivative changes from positive to negative. So that gives you just a quick rundown, and hopefully you don't have too many questions, but if you do, I'm here. I will answer them tomorrow.